Hello, and welcome to our next presentation. On behalf of the MIT CDOIQ Virtual Symposium, we'd like to thank all of our sponsors who have continued to support the symposium during this very challenging year. Before we thank our partners, we'd like to ask that sometime during the symposium's breaks that you visit our partners' virtual booths. You can also visit the Content Hub on the MIT CDOIQ website for some great partner resources. We'd like to thank the following partners: Deloitte, Informatica, Privacy and Analytics, DataOps, Fusion Alliance, KPMG, Sandal Consultants, Tamer, Elation, Ali Data, Big ID, Boomi, Caserta, Citizen, DataKitchen, Garage, Wakira, Pylog, Click, ThoughtSpot, Eckerson, Global IDs, Snowflake, Starburst. And as I said, please make every effort to visit our partners, use the virtual passport, because without them and our partner support, the symposium could not be held. Thank you. Hey everyone, and welcome to session 6B. I hope you're as excited about this as the previous sessions. Session 6B is the art of the possible with DataOps. Now, just before I do a quick introduction to Chris, please note that you have the chance in Slido to enter your questions. And then what we'll do is we'll get Chris to answer the questions at the end there. So let me introduce Chris. Chris Bergh is the founder and head chef at DataKitchen, and we'll discuss how and why data companies are implementing DataOps. Chris, over to you.
All right, thank you, everybody. Let me share my screen here. And so, my name is Chris Bergh, and I'm head chef of a company called DataKitchen, actually here in Cambridge, just next to MIT. And so, what I'd like to do is kind of talk about something called DataOps. And so I just want to make sure I'm sharing the right screen here.
Looks good.
Okay, so you're seeing my deck, the full screen. Okay. And so I'd like to talk about something called DataOps and the art of the possible in it. So if you are seeing my full screen, I'm going to talk about 4 things. And the first idea is kind of like, what is this idea of DataOps? And we've been at the MIT conference now for 5 years, kind of talking about it. And the first year we actually didn't call it DataOps, we called it Agile analytic ops. But we're going to start off almost philosophical and with this phrase, what you do is much less important than how you do it. And then we'll talk kind of about the possibilities of DataOps. And then we're going to go into 4 examples of how people have implemented DataOps, and then talk sort of about next steps, how you can get there. And so this may be one of the few philosophical statements that you see today. And so why in the world would I start with what you do is much less important than how you do it? Well, I think it comes from the realization, and I've been in the data and analytics field for 15 years. Before that, I spent 15 years in software. And in both cases, I've been an individual contributor, a manager, done every sort of job there is. And one of the things I've realized is that to make a team successful, you've got to work not on the thing that they do, but the factory, the building. And to do that, actually, people have studied how to make teams successful, and they're working on a shared, technically complicated thing. And one of the people that I've read quite a bit is Dr. Deming. And when I first started taking over data and analytic teams and finding their problems, one of my first things I thought about doing was blaming the person who created the problem. And what Dr. Deming says is that's often not the case. 94% of the causes are caused by the process, the system, how you do it as opposed to an individual. And so what does that mean in data and analytics? Well, you're probably hearing a lot about things about what's the latest cool model or the algorithm, data pipelines and visualization. As a CDO conference, you're probably hearing a lot about a governance and a lot about the data. I'm going to have a very different view in that the process that you use to develop and deploy and monitor those systems, how fast you can iterate and get things into production, how you can collaborate across the complexity of teams, how you measure the process is much more important. And this is a really contrarian perspective that the tools, the technology, and the data are just much less important than the people and the process and the operations. And
hey,
so,
Chris, do you want to check your camera?
It's not on. Okay, let me see. There we go. How's
Thank you.
that?
Great. Thanks.
So yeah, so there's this contrarian perspective that we spend a lot of time in the industry talking about tools and technology, but at the end of it, it's the people in the process. And so what does that mean exactly? And so in this presentation, and in fact, what I think about DataOps is if you focus on a different mindset, and that mindset consists of kind of 4 items. One is that the cycle time at which you can change things in production or get ideas into production, and really how fast you can iterate and improve, actually has so many good side effects. And then the second is how many errors can you have, or how can you lower the errors? And maybe it's because of poor data quality, or maybe because you're just late or someone did something wrong. And the how can you increase customer data trust? And then the third thing is really talking about collaboration. Given data scientists and data engineers, self-service analytics, and central IT and data enablement, how do you get the Hatfield and McCoys done with sort of less meetings and bureaucracy? And then since we're all analytic here, how do you measure your process? How do you, if you're going to change your focus and mindset and do this? And so, what we see and is that a lot of companies, before they've implemented DataOps, have a very slow cycle time. It takes them weeks or months to deploy 10 lines of SQL into production. And they often have a lot of errors. And the collaboration is difficult. And all too often, they haven't measured their process. And I think the result of that is that most companies have sort of higher costs and less happy customers. And so what does that mean personally? Well, my journey to DataOps is in managing data and analytic teams. And as a person who managed data engineers and data scientists and data visualization, I always felt caught between a rock and a hard place. And that rock was the data providers who forgot that I exist, the systems that went down, and the hard place was my customers who were demanding data trust and perfect data and fast turnaround time when they ask a question. And that sort of made me feel beaten down and disempowered. And I think that's true in a lot of data and analytic teams. And in fact, they just have a hard time creating and innovating, and there's a lack of trust all around. And so I think from our perspective, that DataOps, and that's what I'm going to talk about in this, is the solution to that suffering. And so instead of saying this is our world, that we have to suffer, that we got to go slow, and it's a trade-off, we can only go slow and have high quality, or we go have fast and low quality, that you can actually do all these things, that you can actually have rapid cycles and low error rate and high collaboration and clear measurement. And DataOps, think of it as a set of technical practices and cultural norms and architecture patterns that enable that. And so what does that mean exactly? So let me talk about some possibilities. So, in every organization, we always hear about data silos. And the DataOps perspective, it's more about people and tool silos. And so let's talk about that. Every data, you're going to hear a lot of roles in conferences, data engineering and science, people who do data visualization and self-service BI, people who do data governance and people who do production operations. And, there's just a ton of tools out there, right? Data viz tool, science, catalog, ETL tools, databases, data lakes, lots and lots of tools to make individual contributors productive. But if you look at how teams work, they actually kind of work in a sort of a linked process. So for instance, a data engineer sources a table and someone in data science applies a model to it and create a segmentation. Someone in visualization and self-service may add some data with a data prep tool and visualize it. The poor data governance person tries to actually figure out where all the data comes from. And then the ops person has to put all that stuff into production. And if you look at it from a process standpoint, and sometimes these roles are combined and sometimes they're not. Each one of these has their own separate sort of development, production, QA cycle. And they're linked and unlinked at the same time. And each one has their own particular, peculiar challenges. So for instance, the data science process cycle has got a process of building models, getting features, extracting data, deploying model, and it has its own iterative cycle. And so these processes actually have to work together. And so if we look at it, as everyone knows, we source data from lots of internal systems. But one of the things that I'm going to talk about is think of the work that you do as a factory. And that data goes in one side and insight goes out the other to your customers. And as you work on that assembly line, there are different workstations. And workstations may be a data pipeline, an ETL tool, a data science tool, a visualization tool, a catalog tool, and things are assembled in that process. And so you want to run a factory and be able to produce very high quality products with a very low error rate using the already existing workstations or tools that you have. And the challenge that we also see is that there's a law that is called Conway's Law, and it's came out of computer science and manufacturing, and that the organizational structure is sometimes reflected in the technical structure of the things that you build. And it's not meant as a compliment. And so if you look at it from a pipeline standpoint, we have these, the business customer at the end doesn't know all the steps in between. All they know is that they've got the chart or the model that they want, and it's wrong. And it may come from a line of business team doing self-service, or a team doing data science, or a centralized IT team doing data, but all these people are working together to make it happen. And how do you map that organizational structure into the value that's delivered to your customer? Because at the end of the day, I think value is the only thing that matters. And Conway's Law says that the value that we create is often created in the technical artifacts that we create. And those technical artifacts are divided up suboptimally based on the organizational structure. So if we also look at the work that we do, a lot of teams try to actually, in effect, everyone has some way to take their ideas into production and be able to iteratively innovate, be able to deploy things into production. And you could look at it from an architecture standpoint, like everyone's got a production environment where they develop things and work, but you've often got a development environment or a test environment where you're trying to deploy things from one environment to the other. In production, you're trying to orchestrate and monitor things, and you're trying to manage the technical environment to do it. And so this idea of continuous deployment, continuous integration, continuous environments, continuous monitoring is all part of this idea of DataOps. Because what we're trying to help people do is be able to run a factory with very low error rates, because errors cause lack of customer data trust. They cause your team to have lots of hassles, but be able to pick up a piece of that factory or pieces of that factory and then change it in a very quick cycle time. And to be able to do that when the technical artifacts that you're working are owned by different parts of the organization, and do it in a way that you can, as a leader, be able to measure the process of how fast you can do these things and measure the process of how well your team works. And so this idea of simultaneously focusing on both lowering error rates and the cycle times is difficult. And one of the complexities of it, and this is a bit of an eye chart, is that there's a lot of complexity in our organizations. And if you look at the two columns on the left, the centralized development and production, teams are on the graph on the left, that you can see a centralized development team that's maybe got data engineers and data scientists, and people are doing BI. And they're trying to take their work and then they're trying to deploy it to production, which is like the second column. But oftentimes there are self-service organizations who maybe there's a central development team doing a database, but they're using Click or Looker and Tableau in various lines of business. So actually the development of data and analytics is happening all over the organization. And in fact, if you look at the fourth column, the push to production is happening all over the place. And so we've got this organizational complexity where development's going on, pushing to production is going on, different teams are working together, and the customers don't know who to call, and we're all scrambling when something goes wrong. And so that scrambling, that challenge in being able to work through a process molasses to deploy slow to production, and then have a sort of chaotic reaction when something goes wrong, because it inevitably will, eats up time and causes customers to be slower than they want. And so for the past couple of years, we've been trying to talk about data ops and have customers who said, wow, this sounds really good. I'd like to go faster, and I'd like to have less errors, and I'd like to tackle this challenges of collaboration. And man, I'd like to have a dashboard that shows that I'm an awesome CDO. And so they ask us, well, where should I start? And so, from a data ops perspective, we talk about it, think of it as we're building a system that makes it easier to answer the next analysis. It's not about focusing on the next analysis, it's building that system. And if you remember at the beginning, we talked about 4 characteristics of that system that you're trying to work on. And so in order to work on that system, you've got to know where to start. And if you look at it from a business problem standpoint, some companies chose to focus on their deployment speed, i.e. it takes them a month or 2 months or 3 months or 4 months or 5 months to get a new model or some ETL code from dev into production. Or other companies, they just have too many errors. They're, they're late. The people don't trust the data. They're getting, they're dreading going to work because they get the Slack message that something's wrong. Other companies just have poor coordination and between maybe a centralized team and a self-service team. And there's a lack of governance of self-service, and the IT team feels that they get blamed every time the self-service people go off the rails. And so all these things are perfectly legitimate ways to actually go in and start your approach. And they're not mutually exclusive. But what I'm going to do is talk through some examples of where people started. And so the first company is a European telecom, and they actually suffered from slow deployment. So it took them 4 months to actually take an Oracle database, take new ETL code, Informatica code, some Python code, maybe there were models, other things, and deploy it from development into production. And you can see they've got a development environment, a system test environment, a pre-production environment, and an EDW environment. And why did it end up taking them 4 months? Well, because every time they had an error, they put in a checklist, and that checklist kept going longer and longer and longer. And then to actually move something from one environment to the other, they had no ability to tell. And so the first thing that they said is, well, how do I know if my environments are even like each other? And how do I know I've got the right data? How do I know if when I move something from one environment to the other, it's the same? And so we have a part of our software called the kitchen, because that's our company is named DataKitchen, which is the extraction of their environment. And the first thing to do to be able to move things from one environment to the other is have an abstraction of it, saying, here's my development environment, here's my production environment, and I want to move my work from one area to the other and be able to automate that deployment. And then the second part, and that's a sufficient condition. The necessary condition comes from the fact that when I'm in one environment, how do I prove that what I'm doing works? And so if you look at that graph on the top, those numbers actually represent tests. And so in a development environment, we pour in test data and then run these tests across the entire work that they're doing, insourcing data, transforming data, visualizing data, et cetera, to prove that what you've done is working. And think of it as, in software, there's these terms: functional tests, regression tests, end-to-end tests, and unit tests. All those things are ways that a software development team prove that when they've changed something, that it doesn't affect anyone else. Because one of the challenges in data and analytics is we live with blinders on. And if I'm an ETL engineer, I do my own world and I put my blinders on and I'm done, and I throw it over into this big unknown system and I have no idea if I've broken anything. But I'm done. I've got my blinders on. I did a unit test, or it works on my machine. And what we're trying to do is pull the blinders off the individual to see, hey, if I did make a change, maybe at the back end of this problem, what's the effect of all my customers on that? Am I going to break anything? Is something going to go wrong? And that gives people a lot more confidence and be able to actually deploy things quickly, because they can then take their blinders off. They can see that maybe this small 10-line SQL change did have an effect down the line, and they can tell that before it goes out into production. So automated testing, regression testing, functional testing, based on an abstraction of their test data and their environment, actually makes the sufficient condition to go fast in deployment. So the second case here is errors. And I purposely use the term errors as opposed to data quality or problems, because oftentimes when your customer says there's a problem, it could be, and maybe it's from your source data, or maybe something happened. Maybe a server went down, or maybe something's wrong in the code that's working on the data. You just don't know. All the customers know is there's something wrong, and they're going to call you up and say, hey, what gives with this data? And so how do you actually reduce errors when that happens, especially when you have a really complicated data environment? And this American transportation company did. They had lots of different tools and technologies, and it sort of looked like this. They had vehicles spewing off data that came in two different streaming methods, sort of NiFi and Kafka. They had an enterprise service bus also that was capturing things in kind of a fast batch way. They had batch methods that were taking internal data in Informatica. They had some real-time predictive models and batch predictive models, and all that stuff was being sort of pushed into Oracle. And then notebooks and Tableau were actually being used. And then the data customer would go in and look at a notebook and say, something's strange. And then they'd have to go through, well, where did this strangeness come from? Because the organizational structure actually mapped onto this technical structure. The notebooks were owned by the data science team. The Oracle database was owned by the data warehouse team. The different ingestion methods were owned by different teams. And so massive finger pointing ensued. Who did this? Where's the problem? And so when you have this very complicated error-prone environment, and some cases it's no one's problem. Something happened with the source data. The machine actually stopped working. And the point here is that you want to know if there's problems before your customers do. And the only way I think you can do that is to be able to have a system that observes what happens and monitors and tests it. So what we did is we took another piece of our software and we call this a recipe, and it sits on top of all the pieces here. And you plug all these tools into it. And as these tools are running, it samples the data, tests the data, looks at the data from a statistical process control method and says, something's wrong. You know, for the last 3 weeks, we've seen vehicles of this class generate, 200,000-300,000 rows a week. And this last week, we've gotten 10. Maybe that's a problem, and alert someone through a Slack message, an email, a Jira ticket saying something's wrong. And it's, it's better for your team to know that something's wrong before your customer than them to find it. And while you can, it's data, there's always going to be problems with data. It's much better to say to your customer when there is a problem and they notice it, saying, yes, thanks for pointing that out. That is a problem. We found our provider is giving us poor data. We're going to put in a test that it doesn't happen again. And so testing, monitoring in production, observing all the data and proving that it works is I think, a necessary skill for teams to have to reduce errors so that they can have more time to do more good stuff and stop the finger pointing and Hatfields and McCoys. Because again, it's taking the blinders off. If you're a data warehouse person and you only see the data warehouse and you've got a graph that says, yes, the test failed in the data warehouse, well, you'll know. This ability to get everyone on the same plane when diagnosing problems, I think is really important to be able to fix them and turn them around. So let me go through one more case where people came to DataOps. And I've talked a little bit about the Hatfields and McCoys, and the biggest challenge I think all of us have in data and analytics is self-service. And that, there's great tools like Tableau and Looker, great data prep tools. In fact, everything that you can do in data and analytics now is a self-service, self-service data science, self-service visualization. And when you're working in a central organization and you've got to worry about compliance and security and people using the data the wrong way, and you're the one who gets blamed, how do you actually manage that challenge? Because there is a lot of benefits of self-service. And one option is to take that away, but then you lose all the benefits of the quick reaction time that self-service provides. And so this bank had a lot of compliance challenges. And so they've got 1,000 sort of non-IT users trying to look and get data, get some tools, do some work with data. And so how do you handle this? How do you build a data sandbox or a development environment for those people to do their work? And so if we look at it from a scenario standpoint, I'm a centralized IT person, and there's people in New York who are working on business loans, people in Texas who are working on high net worth, people in the Northwest and on regional branches, and they all have sort of different needs, data they want, tools they want, times they want to have data. And so you could say a person in New York City wants business data and D&B files, maybe in a SQL database. The Texas person maybe is a data scientist and they want to have Python access. Maybe the Seattle person just wants a Power BI dashboard and the ability to play around with the data. And so self-service means kind of self-service data and building sandboxes for people to use it. And if you think of what people would like, or what this organization wants, is they want to be able to give resources to people, data, tools in an environment. And then if they do something wrong, take it back. Maybe they leave the company, maybe they start to export data, maybe they're joining data in. So they need to be able to actively monitor and govern what happens in those analytic development environments. So be able to give all the resources to your self-service users in the nice little basket, but put a wire into that basket and monitor what happens to see if they're going to do anything wrong. And I think that's a fair trade-off between the freedom that self-service provides and the control that centralization needs. And then, the other part is, how do you actually take that and get it into production? And self-service people love to create new insight, a new dashboard, integrate a small data set, but how does that actually get into production day in and day out? And so this isn't in this customer's phase one, but they part of it is they want to have a path to production, because some things that self-service users do, there is no path. They've done an experiment, they've tried it, and maybe it didn't work. And in other cases, they want to actually have it in production. And maybe what you want to do is take that Alteryx workbook, that Tableau dashboard, and wrap it in a tested production environment and deploy it. In other cases, maybe the idea is so good that you want to take that calculation that's ended up in a Tableau dashboard and put it as a attribute of a measure in a data warehouse so everyone can have it and it can earn the right to be re-implemented. But actually having a discussion about what's in production, what's not, what's high quality, what's low quality, and being able to assist these teams who are doing self-service in their path to production is a great work. Because again, if you're building a centralized resource, you want to take your blinders off. And if you make a change centrally, you want to have some ability to see things decentrally. And so the first way that we did this is a simple form-based UI, but our product also supports this. And so let me go to the last case of another case, and really is about collaboration. And this is a different group, not self-service users, but data scientists. And they're kind of like self-service users, but they're different in that they tend to be a talented and expensive resource. And they tend to be very interested in building models, finding data sets, and in the creation activity, just like self-service users, but less interested in actually the day-to-day running. And so this consumer goods company had a team, and they built a nice model that did some kind of a sentiment analysis and showed it to the brand team and the consumer goods, and they loved it. And the data scientist team was wonderful. This is great. But then a week went by and they're running it again, and another week and another week. And all of a sudden it was a few hours of this data science time just feeding the beast that they built. And they wanted to be able to say, okay, I want to push this to another team to be able to run, but I also want to understand it and have visibility and monitor it if something goes wrong, because I may, the problem may be in the source data of the system that the IT team can take of, but maybe I need to tweak and retrain the model, and I want to have visibility. So what we did is actually took that model and put it into our things called a recipe, and that becomes a shared construct that the data science team and the IT team can use, both from a development standpoint and from an operational standpoint. And so by having this kind of shared view where the data science team and the operations team can see, and then be able to take things from one environment in a development environment into production and back into development quickly, allows the data science team and the IT team to be able to work better together. And then most importantly of all, take those overtaxed resources and back them up with operational resources. And instead of throwing things over the wall from a data science team, you have now a way for the data science team and the IT operations team to work together. And so what does all this mean? Well, I think if you look at it, there's sort of two poles in data science and analytic teams today. One is heroes, where I'm doing everything, I'm great, and then they burn out or they quit on you. And then there's the fearful teams where they sort of embed themselves in processes. And so I think if you look at the hero case, don't try to solve problems, try to figure out how to never create them in the first place. And another way to think about this is to sort of love your errors. And when you have a problem, figure out a way. That's an opportunity to figure out how to improve your system, how to build more of your factory, how to invest in your process to do it. And that's, I think, another aspect of what I'm going to talk about here is that as a chief data officer, you own this process. And that this process is, in fact, one of the only things that you can control to actually make your team successful. And you need to start thinking about, instead of where companies on the left, they're spending not enough time on doing new features, new models, new visualizations. They're spending way too much time on meetings and operational tasks and running around from errors. And if you look at it, and Gartner's got a report that backs this up, what we're trying to do is change that ratio and saying, spend more time and get more time to do new features and data for your customers, and less time on these errors and operational tasks. And because we're a believer in iterative development, more time to actually refactor and improve what you already have and reduce your technical debt. Because if you're building a factory and you're trying to build this factory quick, you're going to find cases where you develop something suboptimally and you're going to want to improve it. And so that's my hope, is that we can, instead of hating going to work in the morning, that you've got errors, or having your business customer roll your eyes because they think it should take 2 hours when you told them it's going to take 2 months, be able to improve that. And that also goes to the second benefit that we've seen, is this deployment latency. And a lot of companies are taking, honestly, weeks or months to deploy stuff from dev into production. And we think that's just too slow. It should be hours or minutes. And when you deploy, you should be able to do it with low errors. And in production, you should be able to do it with low errors. And finally, I think, in my experience and many years running data and analytics teams, it's a hard job. You're caught between the rock and the hard place. And I think if you focus on these data ops principles, you can actually have a better outcome, and your team can be more efficient and more happy. And so what does that mean? So let me talk about next steps. So since we're all a chief data officer group here, one way is to think about kind of where your team is on this spectrum. And how many errors do you have? How fast can you deploy? How good is the collaboration between your self-service and your central teams? How well do you measure your process? Have you implemented something like an Agile or a SAFe or a Scrum process? How much is your group focused on the customer as opposed to just fulfilling the process? And we actually have something called the maturity model that we've worked with people to be able to go look at and see where it fits on that, and where each one of your teams do. And we can actually go out and work with you and measure these and compare you to where different teams are. And what we see is sort of the best in class. What's actually quite interesting is the best in class actually do well at a lot of different things. It's not a trade-off. And this is a really interesting, is that most people think, yeah, I run my team and yeah, we're deploying fast, but we have a lot of errors and that's okay. Or I've reduced all the errors down, but man, we've put a lot of process in, so changes are hard. And I've got self-service, so there's always going to be collaboration problems. And I think the idea here is that what best in class companies do, they can do a lot. They can do a lot of these things well. And so if you look at this graphic equalizer, you can actually move all these things up. You can actually improve your cycle time and have many more error-free days and have high calibration and have high process measurement. And you can do it all. And that's a really kind of an amazing statement here, that these trade-offs that are deeply embedded in our gut, that you can actually, that you don't have to do those. And again, this is not magic. It's happened in manufacturing. It happened in software development. And these same sort of a lean and agile ideas and the technical environment and ideas to do it that are supported by DataOps are what we're trying to bring to market. And we think if you do these things and you sort of push up that graphic equalizer, you can end up with lower costs and less unhappy customers. And so how does that work? How can I do data ops today? And so, there's lots of ways. So we have I want to talk a little bit about our company, but the way I came at data ops starting in 2005 was just my life sucked and the bills were breaking and customers were yelling at me for going too slow, and people were being heroes and quitting, and my life was chaos for many years. And what I started to do was read Deming, started to look at what happened in software and think about how to do this. And the first thing is, like, how do you actually deploy faster and increase the cycle time at which you can do it? Well, I think the first thing is just create some automated tests. Don't just hope when you deploy something from dev to prod that it works. Prove that it works by having a set of automated tests, having robust test data, and link those two together. And then the second idea is, how do you lower error rates? Well, what I did was I created what's called a quality circle. So I solved this with Excel. So every time we had an error, someone complained something was wrong, we put it in a row in a spreadsheet. And then every 3 or 4 weeks, everyone who was involved, we'd sit down and have a quality circle where we'd look at the errors and find just one thing to fix. And if you look at that over a year, and you find patterns and errors, and you can see that by looking at your errors and changing your viewpoint of them from shame and blame to opportunities to improve, you see that by taking individual errors out, you actually are improving your data quality, improving your release time, and improving customer satisfaction. And that's all free. Writing automated tests, you can do them in whatever language. Counting your errors and creating a quality circle, that's free. And improving collaboration. Well, a lot of data and analytics is all over the place. Your ETL code is in the database or put in Informatica. Your model code is on someone's laptop. Your Viz code is on a shared drive. Well, why not just put it all in Git? It's free. And that way you know where everything is. And you know where the latest version is. And that's one simple way to help people collaborate. And then finally, on measurement, I think it is really important to, from a leadership standpoint, to start tracking these things. If you've got a spreadsheet with your errors, we'll start tracking your number of errors every week over time. If you're looking at putting things in Git, we'll track how much code is in Git, how many check-ins and checkouts. Count the number of automated tests, and then build yourself a dashboard to be able to look at these things. And so I think there's a very simple way that you can start. And then I think another way to think about it, and this is a bit of an eye chart, but it fits my background. So when I was a software engineering manager back in 1999, and I had developers and QA people, and they're all really trying to do new features, and they're all focused on kind of new features. And we had maybe one person who we called a release engineer, and they were paid less, and they were pushing it to, they were pushing it to our SaaS site at the time. And if you play that forward now to a software team, and this looking at the graph in the lower left here, 23%, 25% of the team is focused on operations, is focused on building a good factory, where 77% are sort of working in the factory. And I think that's the perspective I'd like people to have with DataOps is assign some of your people, 10%, 15%, to be able to focus on building a factory, automating tests, automating deployment, making sure that you can, your factory, your delivery of your systems and analytics runs seamlessly, and that you can measure the results. And I think by rethinking your team effort, you're actually going to get more done. And so by building a better factory, you're going to be able to put more output of your cars, and not, in this case, it's not cars, it's charts, it's models, it's visualizations, et cetera. So stop focusing on that, focus on not what you do, but how you do it. And so the last slide that I like to talk about is, of course, we are a commercial software vendor, and we've got a software product that companies all over the world are using to help do these things, decrease the cycle time of change, innovation, lower error rates in production, and improve collaboration. And I think that's it. And if you want to learn more, we actually wrote a book on DataOps that's free. It's a 200-page book. We've given away 10,000 copies so far. We also wrote a manifesto that has 18 points about what it means to do DataOps. And again, over 10,000 people have signed that manifesto. So, or you can come to our website and learn more about DataOps and DataKitchen.
Hey, Chris, thanks very much indeed. A couple of things. If you want to send us a copy of the link to the recording to the DataOps in the article, we'll post it in our upcoming newsletter, get it out there to the community. Also, I'd like to mention for our attendees to please make sure over the next couple of days you drop by the virtual booth and try and see if we can locate Chris or his team, have a chat with him, talk about more about his solution, how you can actually help you move forward with that. And Chris, just maybe in the last minute, because we do have to wrap up, can you just talk about, the software maturity cycle, life cycle you talked about? Is that something that you have developed your own, or do you use a third-party industry solution for the maturity life cycle?
Model? No, actually, yeah, it's a model that we've developed our own, because there is still, DataOps is gaining a lot of popularity, a lot more. But 4 or 5 years ago, when I came and asked at the Microsoft CDO at this CDO conference who had heard of the DataOps, I think 4 years ago, only 4 out of 200 people had actually heard the term. And so it's something that we've developed. We think it's quite good, but there is no industry standard yet on it. But it's coming. More companies are focused on it, and so we've got an early version of it.
Excellent. And you were driving it. And let me also, on behalf of the symposium, thank you for your, is it 5 years? Is this the 5th year that you've
Here,
sponsored?
yeah.
Well, so we'll have to get that recognition. Actually, one of the things we'll do next year is we'll actually have you up in front of the symposium members and recognize you for your 5 years plus membership of the MIT Symposium. That's really a great effort, and we support and thank you for all your support that you've provided to us over the years. So, Chris, with that, thank you very much indeed. We'll let you go. If you just stay with us, just we'll get Rod to broadcast and cut us out here. So just hang tight for a minute, okay? Thanks, Chris.
Bye.